Welcome back to our sixth video for chapter 4, Effects of Electric Current. And today we're going to study the construction and working of a DC motor. I explained to you in the previous video, DC stands for direct current, where the current flows in one direction only. Okay, so in this case from A, B, C, D. So it's moving in this direction. Okay, now in this case, let's understand some of the components of the DC motor in the first place. The first thing that we have is the rectangular loop made up of copper wire with resistive coating. It's also called as an armature or a rotor. Then we have the north and south pole of a magnet. Then we have two split rings. Split rings mean they are split in the center. They are half pieces. Okay, so we have two split rings, X and Y. These split rings are tightly packed on an axle. So if the split rings rotate, along with it, the axle also will rotate. Okay, but they are loosely brushing against two carbon brushes, E and F. The E brush is in contact with the positive pole of the battery, while the F brush is in contact with the negative pole of the battery. Okay, so now let's understand what is the working of this DC motor. So the rectangular loop of the copper wire is placed between the north and south pole of the magnet in such a way that the arms A, B, C, D are perpendicular to the direction of the magnetic field according to Fleming's left-hand rule. Okay, the armature now is cutting through or is placed perpendicular to the direction of the magnetic field, which is from north to south, right? The two ends of the armature or the rotor or the rectangular loop are in turn connected to two halves of the split rings. The two halves of the split rings, the two halves of the ring, which is actually called as a split rings, have resistive coating on their inner surfaces and they are tightly fitted. The inner surface is tightly fitted on the axle in such a way that the outer conducting surfaces are touching or brushing against two carbon brushes, E and F respectively. When the circuit is completed as shown in this figure here, the current flows in the branch AB of the loop. Okay, so the current flows through AB and then it comes to CD. Now this diagram is slightly different because here the positive pole is on this side. So in this case the current should flow from this direction continuously, that is positive to negative. In this picture you need to understand the positive pole is on this side, so current will continuously flow in this direction. Okay, that does not make a difference which side is the positive or the negative pole. The understanding of it is more important. Okay, so the current will flow in this direction now for this. According to the DC definition, the current should continuously flow in one direction only. That means this part should always be in contact with the positive pole, right? So does that really happen? Let us try and understand what happens next. Now the loop and the axle start rotating in the anti-clockwise direction due to the current flowing through the loop. Okay, when the current is flowing through AB loop, which is on the top, according to Fleming's left-hand rule, when the direction of the force is upward and the currents are moving towards from north to south, that is in the direction of the index finger, okay, a force is exerted downwards. So the loop AB is pushed downwards as the current is going upwards. And on the other hand, in CD, the current is flowing downwards because the current is going in this direction, A, B, C, D, that is positive to negative pole. So when current is going upwards, the coil is pushed downwards. On the other hand, when the current is flowing through CD in the downward direction, the coil is moved upwards, and that creates an anti-clockwise movement in the coil, right? So what would happen now? Okay, now AB is the positive, let us call it as positive pole, and CD right now is a negative pole. But after half a turn, CD will come in this place and AB will go in that place. Because of the split rings, what happens is now DC has come in contact with the brush E, which is the positive brush, and therefore now DC becomes the positive pole and AB becomes the negative pole, because AB comes in contact with the F brush, which is in turn connected to the negative pole. What is making this possible are the split rings, because they are split. Now look at this picture carefully. Okay, first the orange is in contact with positive pole, and after half a turn the yellow is in contact with the positive pole. That means initially AB is in contact with positive pole and then CD comes in contact with the positive pole, because the split ring is moving. However, the brushes are constant. The brushes are stationary. Okay, so the E brush continues to be positive pole, F brush continues to be the negative pole. However, the half ring, that is AB part, which was earlier positive, has after half a turn will become the negative pole and CD will become the positive pole. What makes this possible is the split rings. Okay, if the rings were not split, then the story would be different. Okay, then the current would not really move in this direction, because AB is supposed to be positive and CD is supposed to be negative according to this picture now. But when CD comes in the place of AB, CD becomes positive pole and AB becomes the negative pole. So therefore, the current in the external circuit remains in the same direction. Current will continuously flow from positive pole to negative pole. Initially, it will move A, B, C, D, and then it will move D, C, B, A. Okay, so that is how DC motor has current flowing only in one direction. So the direction of the current remains the same. This is because of the split rings which are taking the place and turning positive, negative, positive, negative. Okay, so I hope you understood how that DC motor works, right? And now the question is, why are carbon brushes used? So let's consider this as our E brush and this is our F brush. They are, as the name suggests, just brushing against the two split rings. And these brushes E and F are stationary. So E brush is always the positive pole, F brush is always the negative pole. However, the split rings that are rotating along with the axle in the that is in the center, they are changing their places. Let's consider this one as the X ring and this one as Y. So now X ring is the positive pole because it's in contact with the E brush, while the Y ring is in contact with F brush, so that's the negative pole. But after some time, this will come here as it rotates. So the Y becomes positive and X becomes negative. So these brushes are actually helping to keep the same polarity, or rather to keep the same poles, positive pole on one side and negative pole on the other side. So in the next video, we'll talk about the generators. So till then, keep studying. Bye-bye. God bless you.